Hello and welcome to another episode of the Hydrocarbon Engineering Podcast. I'm Callum O'Reilly, and today I'm pleased to welcome onto the podcast Jack Blundell, Sales Director for ROCKWOOL Technical Insulation. In this episode, we're going to be exploring innovations within industrial insulation. Now, as all of you are aware, corrosion under insulation is a key system challenge for facility owners that can become a very costly problem due to more frequent repairs, shutdowns, and overall reduction of plant service life. We'll be discussing the problem of CUI in greater detail and examining solutions that can help to reduce corrosion on pipes. So let's talk to Jack.
This episode of the Hydrocarbon Engineering Podcast is sponsored by ROCKWOOL Technical Insulation. Designed for durability and sustainability, ROCKWOOL's high-performance stone wool insulation helps control process temperatures, reduce energy loss, mitigate corrosion under insulation, and enhance fire and acoustic protection. The result? Safer operations, improved asset integrity, and long-term performance across critical process industries. Learn more at www.rti.rockwool.com.
Hi Jack, and welcome to the podcast. How are things with you today?
Great. Good to hear from you, Callum. Yeah, thanks for having me. I'm very delighted to be here.
Great stuff. So Jack, to kick things off for us, please can you introduce yourself to our listeners and tell us a little bit about your role at ROCKWOOL? And also, many of our listeners may be familiar with your company from the insulation that they find in department stores or building merchants. So I was wondering if you could just briefly clarify the differences between this division of your company and the industrial side of your business that you work for.
Yeah, for sure. A little about me. I am, as mentioned, the sales director for ROCKWOOL Technical Insulation. And what I do is I manage the sales in really the eastern half of the United States. So essentially going from North Dakota, South Dakota, and straight down to Texas and really everything east of there. I'm personally located in Houston, Texas, and I have, I guess, coming up now on about 16 years of experience in insulation specifically. My career has spanned different roles, but it's been very engineered focused, I would say, such as technical support, specification management, business development, things like that. And I mentioned ROCKWOOL Technical Insulation. So to answer your question on who the heck we are within the ROCKWOOL family, the ROCKWOOL Group at a high level, it's the world's leading manufacturer of stone wool insulation. And I will say this for yourself and our listeners, you'll probably hear me use the phrase stone wool and mineral wool during our discussion. Just know that I'm talking about the same thing. Stone wool is a specific type of insulation within the mineral wool, a kind of umbrella of insulation types, but most of the time, the industry tends to default to the term mineral wool when describing ROCKWOOL products. But within the ROCKWOOL Group, we call it a diverse range of high-performing insulation products for a variety of industries, but it's all based on innovative stone wool technology. In fact, this year, we'll actually celebrate 89 years since our founders first produced stone wool in Denmark, which is actually where we're still headquartered today. So we're very much we'd like to say a global leader with a local presence. We have, give or take, about 12,000 employees, sales personnel that sell into about 120 countries, and we have roughly 50 manufacturing facilities globally, and we just continue to grow. And we produce everything from building insulation to acoustic ceilings, external cladding systems, even horticulture solutions or fibers for composite applications. But within the ROCKWOOL Group, we do have an industrial segment, which is who I represent and I work for, and that's known as ROCKWOOL Technical Insulation. And this is our division that provides solutions for industrial applications. And we provide really a full range of stone wool or mineral wool products with a clear focus on what we call the process market or marine and offshore market. And if you think within large industrial plants, there are a variety of surface profiles that require insulation. And these plants, they need a diverse arrangement of insulation for different types of equipment. So if you think of an industrial facility, there's a lot of pipes or vessels or columns or tanks or ducts, and just many, many more. So when we say the term technical insulation, though, what exactly does that mean? Technical insulation is also referred to as mechanical insulation to some, and really to insulate piping, as I mentioned, equipment and processes. Most of the time in the world that we live in, typically up to 1200 degrees Fahrenheit. And the types of facilities that, when you think of that heavy industrial, you're talking petrochemical, refineries, power plants, and things like this. But you're right, though, Callum. Many people know ROCKWOOL from the insulation that they see in, I guess you could call it, do-it-yourself or home improvement stores. At least here in the U.S., you think of stores such as Home Depot or Lowe's. That's kind of our building insulation division, which focuses on thermal and acoustic insulation for construction of like homes and commercial buildings, that sort of thing. So our technical insulation division is a very different ballgame, though, from building insulation in that, I guess, the performance requirements.
Great. Thanks, Jack, for providing some clarity on that for us. So, Jack, you already touched upon this, but as an introduction to any of our listeners who may be unfamiliar with the ins and outs of industrial insulation, can you explain a little more why insulation is typically used in facilities such as refineries or chemical plants? And where in those plants is it typically used?
Yeah, for sure. That's a great question. In an industrial facility, if we take such as a refinery, insulation, it does serve many, I would say, critical functions. I guess arguably the most important is always going to be personnel safety. So, in industrial plants, equipment operates at extremely high temperatures, very often up to, as I mentioned, 1200 degrees Fahrenheit, I guess 650 Celsius, or even higher. I mean, insulation, it really acts as a critical thermal barrier, so protecting workers from accidental contact with hot pipes, vessels, equipment. And this really is I guess you could call it a non-negotiable safety requirement. It has to be done. Another reason would be like energy efficiency and I guess cost savings. So insulation, it does help minimize heat losses from hot processes. And by reducing those thermal or heat losses, plants can consume less fuel or energy to maintain, I guess, process temperatures. And this would result in, I guess it could be significant operational cost savings over a long period of time. And then another one would be process control, called process control or temperature stability. Many processes require very precise temperature maintenance for a certain reaction to proceed correctly, safely. Insulation, it helps stabilize temperatures by reducing external environmental influences, ambient temperature fluctuations, wind cooling, things like that. But ultimately, insulation can help ensure consistent product quality and the yield of the output that's being produced. I guess another important one would be equipment protection and just extending the asset life, really. Insulation actually can help shield pipes, vessels, equipment from a lot of detrimental issues. So things like external corrosion. We're going to talk a little bit more about corrosion, I'm assuming, today. So if you think, especially in coastal marine environments, so there's a lot of corrosion that can happen. Mechanical damage, vibration, environmental degradation. So a lot of these kind of external factors that can be detrimental. And probably a good one to mention too, not always thought of, but very important, are even environmental or regulatory compliance. So insulation does help reduce emissions and heat radiation to the atmosphere, helping facilities. Typically, they have to meet certain environmental regulations, and they even have internal sustainability targets, right? It also can support compliance with safety standards and really just guidelines for plant operations. And where it's used, insulation, it's everywhere in a facility. We mentioned a refinery or even a chemical plant. You'll find it on hot process pipes, wrapped around distillation columns, heat exchangers, reactors. You'll see it on steam lines, exhaust stacks, fire heaters. We'd like to say essentially anywhere that heat needs to be managed or contained is typically where you'll find insulation.
So, Jack, you mentioned corrosion, and I definitely want to touch upon that in a little bit more detail. So, are there areas of the plant that are more exposed to corrosion or perhaps at higher risk of it happening? And why does corrosion under insulation remain such a persistent problem despite decades of awareness and standards?
Yeah, for sure. Certain areas face much higher corrosion risk. I'll say corrosion under insulation, we always joke, it's the Rubik's Cube of the insulation world. Everyone's trying to solve it. But if you think of areas that do face higher corrosion risk, just to name a few, very coastal and say offshore facilities, salt spray, for example, salt water in there, it's incredibly corrosive. The marine environment itself really accelerates the degradation of assets. Tied close to that are obviously areas with high humidity, so tropical climates or even temperature climates that are just near water sources. So high humidity, coastal, offshore, like those kind of go typically hand in hand. But also piping in hot service. So carbon or stainless steel pipes, that carry hot fluids are particularly vulnerable, especially if they are operating with what is scientifically proven to be a high risk range. What is that? Typically, what's considered high risk? It's around 120 Fahrenheit to 350 Fahrenheit. Ballpark in Celsius, that's around 50 to 175 Celsius, give or take. That's considered a very high risk temperature, operating temperature for, I guess, kind of that carbon and stainless steel piping. But it can become an even higher risk, though, of occurring if the system itself is going through temperature cycling. So if it's going up and down from hot to cold, because that's really what it's doing is it's driving moisture to accumulate in the system. But then there are other areas, joints and penetrations of the system. If you think about it, where insulation isn't continuous or maybe butted up nicely against itself and runs a pipe. So when you don't have continuity, water can seep in. It finds its way in. But, why, I guess, CUI, corrosion insulation, remains persistent. It's a fascinating but also frustrating problem. Despite decades of awareness and even very specific standards, and I'll talk, I guess, a little more about this as in our discussion probably. AMP, for example, they have a standard called SP0198. We still see CUI, but here's why. Water always finds a way in. It's inevitable. Even the best performing insulation can experience water ingress through cracks, damaged metal jacketing, areas of pore installation, or at the joints, as I mentioned. And once water gets under the insulation, it creates a corrosive environment it's really hard to monitor or access. And also, it can be an out of sight, out of mind problem. Insulation, it hides the pipe. So you can't see corrosion that's happening underneath. And a lot of times, by the time plant owners discover it, significant damage has often already occurred. And then I would say one of the most important things or critical factors is that the installation quality varies. Again, we always like to think you can have perfect insulation, but imperfect installation is usually your biggest problem. So the insulation is only as good as its installation. So poor workmanship, shortcuts, or even inadequate maintenance, that can really compromise. It could compromise the whole system. Standards, there are insulation standards, corrosion standards that exist, but I would also say that the enforcing those, that can also be inconsistent. Many of these large industrial facilities, as I guess a lot of the listeners are probably aware, is they operate with aging old insulation systems that I guess predate modern CUI standards that weren't installed really to what should be the best practice. So I guess the question becomes, is there a solution? Well, the very quick and honest answer is no. There isn't a one-size-fits-all answer to completely solve, I guess, the CUI problem that's out there.
So is the corrosion on pipes the main reason why pipes are typically painted? Or are there other reasons for this, such as safety identification or anything else, Jack?
Callum, I will be the absolute first to admit I am certainly not a paint or coatings expert, more of an insulation expertise. But from my experience and my knowledge, I guess painting or coating a pipe, it can serve multiple purposes. And as mentioned, corrosion protection is certainly one reason. A high quality coating can provide a barrier against moisture and atmospheric and just corrosion. However, I would say it's not foolproof, especially in extreme environments. And with that, my opinion, and I think a lot of even insulation manufacturers would agree, is that a coating or a paint is always going to be the best line of defense against a CUI. Metal jacketing, that's always a first line of defense of keeping water out. And having, I guess, the right insulation choice can help mitigate CUI. But a coating is always going to be the proper best defense. But there are other potential reasons why a facility would paint pipes beyond just corrosion protection. It could be even like safety identification of a pipe. I do know that sometimes different colored paints indicate the contents of a pipe. For example, you might see red for fire safety systems, or you could even see yellow for caution areas. This is vital in, I guess, a busy, say like a refinery where workers need to know instantly what they're dealing with. So It could even be, again, maybe this is a little bit of my lack of expertise, but from my knowledge, it could even indicate temperature. Sometimes a certain color or a coating or a paint could indicate whether a line is hot, cold, at ambient temperature. It could even be maybe even regulatory compliance. So many facilities are required by law or standard to color code their piping systems for safety. Or just very simply, it could just visual inspections. Paint makes it easier to spot damage, leaks, maintenance issues. So I think that there are many safety and operational aspects probably for consideration there, to be honest.
So I wanted to circle back to a point that you made earlier, Jack, where you mentioned that all insulation systems ultimately face the persistent challenge of water ingress. So in light of that, is there a perfect insulation that plant owners should be looking to use?
Perfect question. There really is no such thing as quote unquote a perfect insulation system. And that's something that, the listeners and every plant manager, I'm sure everyone agrees with, but really should understand. Every insulation does have pros and cons. There are, I would say, insulation types that are certainly better suited to specific applications, but really the owners, I would say the key design and performance criteria, those really should drive the right, insulation selection. So all insulation materials though, whether it's mineral wool, as we've talked about, could be something like an aerogel, perlite, or anything else. They all face, the persistent challenge of water ingress. Water, we like to say water is relentless and it can enter through, as we mentioned, some different things like damaged or degraded metal jacketing or cladding, gaps in the joints and penetrations, even like micro cracks that could develop over time. We talked about temperature cycling and the condensation that can happen in those scenarios. I guess the key isn't finding a perfect material. It's about selecting the right insulation for your specific application, installing it properly, and maintaining it proactively. So in my opinion, that means choosing an insulation with, at least water repellency properties or characteristics, using a high quality jacketing system, ensuring proper installation and sealing when it requires it of all the components, and really that regular inspection and maintenance. But I would say, to answer your question, there's really no magic bullet, if you will. But there are definitely better and worse choices that can be made when it comes to the right insulation, for sure.
So mineral wool insulation is often considered quite a squishy insulation that usually absorbs water. So has ROCKWOOL done anything to improve this? And are there any products that can help with corrosion on pipes?
Yeah, man, you're right. The traditional mineral wool that has historically been more moisture absorbing, it has been more moisture absorbing, or squishy to use your phrase. We hate the phrase, but people say, oh, it's been a sponge. But this is why it has faced criticism in applications that are prone to water ingress. One challenge that ROCKWOOL continues to overcome is that hurdle of historic perception and opinion that stone wool and mineral wool, that it's not a good choice for any system that might be exposed to water or even something that would contribute to CUI. As with any new insulation product that makes large innovation leaps forwards in terms of performance, it really takes time to introduce the technology. You got to prove the concept, and you have to build trust, again, over time, that your developments or your innovation are working and that they're adding value. Now, insulation decision makers rely very heavily on fact-driven data. Probably no mystery there. And ROCKWOOL has been very committed to working closely with subject matter experts and specifiers by providing necessary technical support and just looking to help solve their existing corrosion under insulation challenges. It's critical to be a trusted advisor to the industry and really provide non-biased, at least, recommendations that will enhance the plant longevity for owners. You want them to come back to you to be a trusted source, not just for your products, but for information. But with that, though, I will say ROCKWOOL has made significant advances in recent years. If you go back to 2017, ROCKWOOL at that time introduced a mandrel wound pipe section with what was called WR Tech. And this was our response to a really urgent need for water repellency in as you mentioned, the squishy stone wool product. What does WR-Tech stand for? It stands for Water Repellency Technology. And essentially, WR-Tech it's a hydrophobic additive that coats every individual fiber within the stone wool insulation during the production process. And it's an inorganic resin-based additive that has proven to be water repellent. And how is it proven? There's a go-to, very well known, it's an industry adopted and accepted test known as the EN 13472 test. Basically, it's a test where the material has to prove that it doesn't absorb a specific amount of water over a given period of time. So that WR-Tech, that water repellency technology, it really bridged, I would say, the water resistance gap and put ROCKWOOL's stone wool in a class of its own. But that was, again, back in 2017. Have there been developments since then? If you fast forward to today, ROCKWOOL has taken our WR-Tech pipe sections and added another feature to that product in terms of CUI mitigation, probably our biggest innovative development. We've developed what's called ProRock's PS965, the product with what we call CR-Tech, and that stands for corrosion resistance technology. And this is the industry's first stone wool insulation with we call it a built-in corrosion inhibitor. If you look at very rigorous industry testing, this CR-Tech has proven to achieve at least 5 times better corrosion mitigation versus other alternatives that exist on the market. Now, when I say 5 times better, this has been proven using multiple test methods, but the most important probably for the listeners to be aware of is how can you prove in a lab setting that a corrosion inhibitor or that corrosion or insulation is not happening? There's an important test for the listeners to be aware of, or any specifiers out there, known as the ASTM G189. Basically, it's a test that is used to simulate, as best you can in a lab setting, what we would call an accelerated corrosion environment. And then it compares corrosion rates of different combinations of insulation systems. But to answer a question that folks might have is, how the heck does this CR-Tech work? What is it? In a nutshell, the CR-Tech, it's an embedded inhibitor that's embedded into the inner surface of the stone wool insulation, right where the insulation is touching the pipe, the carbon steel, the stainless steel pipe. So right where it's touching the pipe. And what happens is that when that inhibitor comes in contact with water, let's say that water that ultimately tends to find its way into any insulation system, when it comes in contact with the water, the inhibitor is quote unquote activated. And what it does is it forms a thin passivating layer that is ready to help neutralize corrosive environments. So what it's doing is it's buffering the corrosive environment under the insulation by forming a protective corrosion mitigating film right on the metal pipe substrate. And since the WR-Tech that I mentioned is also a built-in solution into the new CR-Tech pipe product, we always like to say this is a belt and suspenders package. So you're getting a 2-in-1 kind of insurance approach. And again, this product is called ProRock's PS965. And what it's doing is you're getting a unique combination of water repellency with the WR-Tech and corrosion inhibition with the CR-Tech now in one product. And it really has an improvement to shield the pipes from CUI. Probably a long answer to your short question. Yes, ROCKWOOL, we're very proud that we've done, I would consider it substantial work to prove the squishy, sponge kind of historic perception of mineral wool, and really take that and improve that mineral wool performance for those harsh conditions. And yeah, that's what we've done the last few years.
And are there any other key features of mineral wool insulation that can help improve safety in a plant?
Yeah, great question. So much of insulation, right? A lot of folks, we need thermal protection or we need corrosion resistance. And there is a lot more to it. So beyond thermal protection and these type of things, I guess mineral wool specifically, it does have a lot of a good additional what we call safety advantages. One of them being fire resistance. So that always helps improve safety in a plant. Mineral wool, it's a non-combustible material and it has excellent fire properties, which if you're talking about things like refineries, mineral wool, there are solutions out there, ROCKWOOL has them, that include a 2-hour, what we call passive fire protection solutions. And that's through an important, well-known industry test called UL 1709 regarding hydrocarbon pool fires. So if you think of refineries or chemical plants where fire risk is a constant concern, this is a very critical property that folks should want to have in an insulation. In addition, mineral wool doesn't fuel, you don't want it to help fuel a fire or produce toxic smoke. So fire resistance is certainly additional feature that will help improve, I guess, safety in a plant. Another key one, which I always like to say it's like the sweet science of a mineral wool, of an open cell insulation material, is acoustics or noise reduction. Mineral wool very drastically helps reduce noise that is generated from pipes or equipment, which that can help improve working conditions on mineral wool. Just for the listeners to be aware, are there standards that exist that kind of govern noise reduction? And there is, and mineral wool meets all the classifications for noise reduction, which deals, I guess another way of saying it is insertion loss. And there's a standard that exists called ISO 15665. And so that's really been the go-to industrial noise reduction standard for heavy industrial facilities if you're talking about acoustic. Sometimes a forgotten thing that mineral wool can just naturally provide for how the material is structured. I guess another one, if you think of it as to safety in a way, is you want the insulation to be very durable. So a properly installed mineral wool system that can withstand vibration, mechanical impact, and just the rigors of a very busy industrial environment. You don't want a material that will degrade, I guess, as quickly as some alternatives. So that's another feature that can improve longevity, safety. But also tied with that is, I guess you want it to be accessible for inspection. Mineral wool systems can be very easily removed and reinstalled for pipe inspection. And this is critical for monitoring things like CUI, and then they can be reinstalled. But this material maintains, I guess, all of these safety features. And then with this new product that I mentioned, this ProRox PS965, you're also getting the added benefit of water repellency that I mentioned. So within the mineral wool family, it's a very thoughtfully engineered product for the rough and tough oil and gas environment. Yeah.
And finally, Jack, are there any industry resources or organizations that you can recommend to our listeners if they want to find help or support in learning more about insulation in general?
Yeah, absolutely. Education is always key, right? If your listeners want to deepen their knowledge about industrial insulation, there are several excellent resources. One that immediately jumps out in my mind is the National Insulation Association, NIA. Essentially, NIA it's a trade organization that provides essential educational training and networking opportunities to its members. NIA is our governing body that keeps the insulation industry up to date on the latest in industry trends, technologies, things like that, and just a lot of great a lot of good reading material. I would say too, within the structure of NIA, every region has usually a contractor association. I'm talking, I guess, specific to the US here, but there are contractors associations built within NIA that are specific to different geographies. And they meet twice a year, but it's always a good place to not only network with like-minded people, but just to learn new things about new technology, trends in the industry, projects, things like that. If listeners really want to deepen that knowledge, that's a great place to start. To peel, I guess, the onion layer back a little bit, if you dive a little deeper, you say, okay, that's fantastic, learn the basics, but I want to learn more about corrosion or corrosion prevention. I would typically direct people to, we call it AMP or AMPP, what used to be known as NACE, the National Association, I think, for Corrosion Engineers. It's now known as AMP, which is the Association for Materials Protection and Performance. AMP is, I guess it is the largest global community for corrosion and coatings expertise. And they're very dedicated to advancing, I guess, the technical and the practical expertise in corrosion prevention, but also control. And I mentioned it a little earlier, but they publish standards as well on CUI prevention. And to direct the audience to one, I would, for educational and to just learn, what is the gold standard of expertise? Is there something out there? It is called the SP 0198. And I would direct folks to that standard just to learn more. But their resources, AMP's resources, are invaluable for understanding, I would say, best practices. And then just to pitch it out there, obviously, insulation manufacturers. So ROCKWOOL, for example, we offer a variety of technical support, product documentation, and really just guidance on selecting the right insulation for your specific application. Our team can help with everything from initial selection to installation best practices. I would encourage anyone working in heavy industrial, oil and gas to engage with all of these resources. A little extra knowledge about insulation could go a long way. And I would also say this too, whether it's ROCKWOOL or any other insulation manufacturer, I would like to think that we all do a pretty good job of taking our biased hats off for our company. We always want to provide the best advice for the right application, right? If my product is not the right one, I'm not going to try to force feed it or recommend it. I'm going to recommend, here are a variety of products that will be best suited to meet the specification, the key design criteria. Even just reaching out to insulation manufacturers, everyone's always very willing to help. But yeah, I would say these probably are the three best things that jump out in my mind.
Thank you so much, Jack, for shedding a little more light on the problem of corrosion under insulation and for guiding us through some of the innovative solutions and wealth of resources that are available to help facility owners address this issue and ultimately achieve greater water repellency. We really appreciate it.
Yeah, absolutely. No, thanks for having me. It's a very important discussion. It's the key topic in the insulation world. The more knowledge and eyes we have on it and the more education, the better. So this is great. Yeah, thanks again for having ROCKWOOL. It's been a pleasure.
A pleasure, Jack. Thanks very much. That brings us to the end of today's episode. A big thank you to Jack for sharing his insights into the challenges of corrosion under insulation and the innovations helping plant owners manage this persistent issue. This topic is also covered in a recent article that ROCKWOOL Technical Insulation prepared for the spring issue of our Tanks and Terminals magazine. Now, this piece explores how recent advancement in stone wool insulation are helping to keep storage tanks safer from the costs and risks of CUI. Now, if you haven't done so already, you can read the article by signing into your account over at our website, hydrocarbonengineering.com, and downloading your free copy of the spring issue. As always, thank you for listening, and be sure to subscribe to the podcast to ensure that you don't miss future conversations with experts from across the downstream oil and gas sector.
This episode of the Hydrocarbon Engineering Podcast is sponsored by ROCKWOOL Technical Insulation. Designed for durability and sustainability, ROCKWOOL's high-performance stone wool insulation helps control process temperatures, reduce energy loss, mitigate corrosion under insulation, and enhance fire and acoustic protection. The result? Safer operations, improved asset integrity, and long-term performance across critical process industries. Learn more at www.rti.rockwool.com.